Hi, this is Tom, amateur call sign N8FDY. And today, another meter review. This time, we're going to do the Bryman BM869s. This is an enhanced package sold by W Electron in Germany. Of course, somebody told me you should pronounce the W as V, so maybe it's V Electron in Germany. And they had an option to include the case, so it cost a few more euros, but I really like it with the case. So when you buy it that way, they actually put it in the case for you and package it in a different box. So let's see what. I put the marking myself on here because I do have, I think, about 4 Brymen cases, so I had to mark what's in each one so I don't pick up the wrong thing. Let's see what's in here. All right, you have your manual, and it's pretty extensive. A nice pocket for it. You have your thermocouple, and there's your Cat 4 protectors for your probes. And you have some nice probes. And these are gold plated. And they come with little banana adapters screwed on. So you can unscrew those, and they look like normal probes, but both the adapter and the probe are gold plated. They kind of feel like silicone. They have that kind of grabby. They're pretty flexible. I don't know if they're not really as flexible as the Probe Masters, but they're very close, very close. And they are gold plated, so I think you can keep these and not worry. We'll test those later. And of course, we have the meter. That's right. You have Velcro to strap it in. You also can strap in the leads with this Velcro. Other bags I have actually use like an elastic band, but I like this Velcro. As long as I remember that's what it is, and not try to yank at it. This meter has a dual display that'll show 2 measurements at once, such as AC voltage and frequency. It has the beep jack function, which is a way to warn you that you have the leads in the incorrect position when you're doing current or not current measurements. It has an AC bandwidth of 100 kilohertz for voltage and 20 kilohertz for current. It has a min-max function. It has a crest function, which is kind of like a peak hold. It also has a 500,000 count option for DC voltage, but if you don't select that, then everything else is 50,000 count. It has relative zero function, or sometimes we call it delta. Of course, it has automatic and manual ranging, and it's got auto power off, and it has a backlight. Well, let's turn the meter on, and we're going to hold the select down to disable the auto power off. Now with most Brymen meters, at least all the ones I've ever tested, it remembers where it is, what you selected on each indent of the rotary. So let's see. Here we have diode test, which is what's the last thing I used with this, but you can see the default is capacitance. So let's change it to capacitance. Now we'll turn it off. Turn it back on. And it stays at capacitance. Let's switch it back to diode. Let's turn it off. Let's turn it back on. And it's back at diode. So for all of these, it remembers the last thing you selected. That can be convenient, but if you're not used to it, it can be confusing. Here we have 2.5005 volts DC, and the meter says 2.5008. That's pretty close. Here we have 5.0009, and the meter reads 5.0014. Here we have 7.5016, and the meter reads 7.502, which is okay to round up. Now you notice when we switched from 5 volts to 7 volts, we lost a digit of resolution because this is a 50,000 count meter. So anything over 50,000, it's got to slide over by one, so you lose a digit. Here's a 10.0015, and it reads it as 10.002. So again, it's okay to round it up a little bit. Let's take a look at the other voltages I measured earlier on this meter. As you can see, all the DC voltage measurements I made met the specifications as stated in the manual. The input impedance for the voltage DC range is 11 mega ohms, and the millivolt DC range is 10 mega ohms. This is 4.99903 volts coming from the DMM check at a 100 hertz square wave. And this reads it as 5.0010. And it reads 100 hertz. Now we're going to do some AC voltage at 60 hertz sine wave coming out of my arbitrary waveform generator. We have 1.0046, and the meter reads it as 1.0048. So pretty good. So a little bit of drift, but it's okay. It's very close. Here's 2.0054, and we get 2.0058. Notice the tendency is to drift up a little bit. Here's 3.0137, and we get 3.0133. 132. Pretty close. Just that little bit of drifting. Let's take a look at other AC voltages I tested on this meter previously. As you can see, the meter met all the specifications as stated in the manual for each measurement I made. 1 volt 3 dB cutoff is 760 kilohertz, which is way higher than the specifications said. So that's pretty good. This meter can do AC plus DC, true RMS. To do that, this takes the true RMS AC voltage and squares it, and then takes the DC voltage and squares it, adds it together, and then takes the square root to get the true RMS AC plus DC. So we're going to feed in a 3 volt AC signal, which you can see there on the meters, and we're going to feed that along with a 2 volt DC signal. Let's double check if we got the DC. That's very close to 2 volts. Very close to 2 volts, 1.996. And now we'll see what the AC plus DC is. All right, 3.6106. And the fluke thinks it's 3.6067, which are very close. So if we square 2, 2 times 2 is 4, and we square 3. 3 times 3 is 9. So it would be 13. And we find the square root of 13. Give me the square root of 13.
It's approximately 3.6055.
Yep, 3.6055. So they're both not exactly right, but they're pretty close. Let's take a look at some other AC plus DC measurements we took previously. As you can see, the meter met the specifications as stated in the manual. I also want to take the time to point out that this meter can also measure decibels. So let's try that. First thing we have to do is have a 50 ohm resistor. And as you can see by the meter here, it's a 50 ohm resistor. Then we have to hook that up to the generator. The arbitrary waveform generator is putting out a signal at 50 ohms, which is why we need to terminate at 50 ohms. We've adjusted these meters so that they use 50 ohms for the reference. So let's see that. Okay, see, it said 50. It says 50, and if we put this one in, you'll see that it's set to 50. Let's plug in the signal to everybody. So I have the generator set to put 0 dBm. And according to this, it's very close to 0. We got 0.04 dBm on the Brymen, and we got 0.05 dBm on the Fluke, so that's pretty close. Let's turn it up. Let's go up to 10 dBm. And we get, 10 on the Brymen, 10 on the Fluke, 9.99 on the Fluke. Let's take her up to, now this is at 60 hertz. So let's take it up to 5 kilohertz. So, at 5 kilohertz, Fluke still reads 99.8, and this reads 99.8. So, let's go to I don't know if this will read up to 20. Let's try. There's 20 dB. 19.99. 19.99. So. And let's try. Minus 10 dB. Well, Brymen says minus 10.15, and the Fluke says minus 10.31. So it does read pretty close. I'm not going to guess at the accuracy because I don't have a meter, well, outside of the Fluke, which was, well, they don't say calibrated, they just give you test figures when you get the 289. And I don't even know if they test the decibels. But anyway, we're going to say, well, you can always find out for sure by measuring the voltage and then doing the calculations yourself. But it's so much more convenient to have the meter figure out the decibels for you. All right, let's move on to current. First, we're going to measure some AC current using the DMM check. We're going to have 0.999675 milliamps at 100 hertz square wave. And it reads it as 0.985. Here is 0.89 microamps, and the meter reads it as 0.89 microamps. That is excellent. Here is 9.21 microamps, and the meter reads it as 9.21 microamps. Another excellent reading. You may wonder, how do I know what the values are? Well, I use a Keithley DMM 6500 that was calibrated early this year. And I use that to make all the measurements. It's a 6.5 digit bench meter, and it's about 10 times more accurate than any of these meters. And I take all the voltage, resistance, current, capacitance measurements with that meter and write them all down. And if I'm using variable voltage, because I have to do that with some of these higher voltages, I put it in parallel with the meter so I can read what the Keithley says it is versus what the meters say. And now I usually measure the meters in groups, and I take a picture of each reading, so that way I can always go back and make sure I put the right number in the spreadsheet. So, well, here's a picture of me doing that now. This is one of the pictures of the readings. So that way we know that the Keithley is pretty accurate, so we know how well we can judge the accuracy of these other meters. Here is 99.0 microamps, and this reads it as 99.05. Here's 131.8 microamps, and it reads it as 131.93. Here's 1.00 milliamps, and the meter reads it as 1.006. Oh, 6, 7, little drift there. Here is 9.98 milliamps, and the meter reads it as 9.993. Here's 99.4 milliamps, and the meter reads it as 99.45. Pretty good. Now let's take a look at other current measurements I made with this meter previously. As you can see by the green, all the readings met the specifications as stated in the manual. These shunt resistors for the current, we have 0.02 ohms for the 1 amp. We have 0.02 ohms for the amps range, 1.77 ohms for the milliamps range, and 101.93 for the microamps range. Let's compare the accuracy specifications for voltage and current for this group of meters. For this group of 50,000 count meters and 60,000 count meters, the Bryman BM869s seems to be the most accurately specified for voltage. And it's still pretty good for current, especially in the AC range. Now it's time to measure some resistance. Let us zero out these leads. 0.12 ohms. 0.11 ohms. Let's zero them out. All right, let's make some measurements. Here's 1.004 ohms, and we get it as 1.05. Here's 10.007 ohms, and it reads it as 10.02. Here's 100.069, and it reads it as 100.1. Here's a 1.0001 kilo ohm resistor, and it reads it as 1 kilo ohm. Here's a 10.002 kilo ohm resistor, and it reads it as 9.999. Here's a 100.02 kilo ohm resistor, and it reads it as 100.02. Excellent. Here's a 0.997 mega ohm resistor, and it reads it as a 0.9941. A little bit of drift. Here is a 9.97 mega ohm resistor, and it reads it as 9.952. Well, let's look at the accuracy of these resistance measurements. Well, all the resistance measurements met the specifications as stated in the manual. This meter could not read the 100 mega ohm resistor, but most meters can't read anything over 60 mega ohms, so that's not really a problem. The voltages used to test the resistance in the low range was 2.93 volts. In the medium range, it was 1.05 volts. And in the high ranges, it was 0.54 volts. Now let's do some capacitance measurements. Well, we could zero out the leads, but according to this meter, there's nothing to zero out. That's suspicious, but we're going to have to go with it. Now with my current measurement scheme, I am skipping the two low-end ceramic capacitors, the 10 and the 100 picofarad. We're going to start with the 1 nanofarad film capacitor. Here's 1.005 nanofarad, and this reads it as 1.02 nanofarad. Here's 9.921 nanofarad, and the meter reads it as 9.95. Here's 99.51 nanofarads, and it reads it as 99.6. Here's 1.005 microfarads, and it shows it as 1.011 microfarads. Here's 10.294 microfarads, and it's 10.91 microfarads. Here's 112.2 microfarads, and it reads it as 112.0 microfarads. A little bit of drift. Here's 944.5 microfarads, and it reads it as 0.986 millifarads, which is really 999, well now 1,000 microfarads, 1,001. Let's take a look at the accuracy of these capacitor readings. All the capacitor readings met the specifications as stated in the manual. Let's look at the capacitance and resistance specifications for this meter as it compares to the other meters in this 50 to 60,000 count group. The Bryman BM869s is probably the second most accurate meter in the capacitance and resistance range. It looks like it's only beaten by the Fluke 289. It's time for some diode reading. And let's start with our favorite diodes, LEDs. Here's a red LED with the forward voltage, and it's a teeny bit dim. Here's the yellow diode with the forward voltage. Here's the green LED with the forward voltage, and it's pretty dim. Here's the forward voltage of the Schottky diode, and no beep for the good diode. So this meter does not beep when it checks diodes. Here's the forward voltage of the small signal diode. Here's the forward voltage of the rectifier diode. Now it's time for continuity. Let's get out the probe masters. Tangled up probe masters. All right, let's give them a try. All right, let's see how fast. They're fast enough. That's good. Now let's try the native leads, since they are gold-plated. All right. Let's take off the banana adapters. And let's see what happens. That's pretty good. Let's see how fast. Pretty fast. Let's put these back on so I don't lose them. Because on my Bryman 789 meter, I lost those. And then when I wanted to use them, I was very sad. The Greenlee DM860A, which reminds me, this meter seems exactly like that meter. And as a matter of fact, here is that meter. So yes, they are exactly the same. And except one says Greenlee on it, and it comes with the Greenlee limited lifetime warranty. The other one says Brymen on it, and it comes with the 1-year Brymen warranty. So if you live in the US and you want the Greenlee warranty, you could get this meter. The meter costs, I think, $150 more than if you buy it from the original in Germany. And you're saying, why did you buy the Brymen then if you already had an identical meter? Well, this meter was really good, except in the low DC volt ranges, it messed up. It didn't meet its accuracy specifications. And I wanted to find out, is that a Brymen thing? And all the Brymens do that? Or is it just weird with my meter? So I ended up finding this one. Like I said, it's a lot lower price. So I decided to get it and find out. And sure enough, this does not miss any of its specifications. I retested this one, and it missed different voltages. It missed the specification on different of the DC voltages, but it still missed some specifications. Now that puzzles me, because usually a meter that misses, I can go back a month later and test it, and it misses the same one. But this one changed which ones it missed. So I'm still perplexed by that, but and I know I should probably send it to Greenlee and tell them to test it or fix it, and I may do that. But anyway, I just wanted to show you that they are identical looking and performing, except that this Greenlee had a few hiccups on making its specifications. This meter does logging. It will record to a PC, but you need to buy the extra cost USB interface. And that is about $34, depending on the exchange rate for euros. And you can see it runs under Windows 11. I also ran it under Windows 10. And you can graph with it. It's a 9-volt battery. It's kind of the older meter designs which use 9-volt batteries. You cannot get to the fuses from the battery compartment, though. You have to take the whole back of the meter off. And the front of the meter, because it actually is, they're in the front. And here's a close-up of the fuses. Well, let's take a look at the pros and cons of this meter. Well, the good parts of this meter is it's third-party safety tested by UL. It meets all the specifications for all measurements taken. It's pretty much the leader in accuracy specifications in many categories. And it has the dual display, which can show you AC voltage and frequency and some other things. The only bad parts of this meter is that the USB interface is extra cost option. Like I said, it's only about $34. There's no Bluetooth support, which is a shame because less expensive meters have Bluetooth interfaces. And you have to disassemble the meter to change the fuses. If you need support in the USA and you're willing to pay for it for this limited lifetime warranty, you could get the Greenlee. But if you're okay without that support and you want to save, I don't know, about $150, go with the Brymen from the Electron in Germany. I like this meter. I like Brymen meters. The only really thing that bugs me is the short backlight time. It is too short. I wish they had an option to disable the backlight off, but they don't. So yeah, accuracy-wise, if you don't need a graphing meter, and I mean this will graph if you hook it up to your PC and you buy that optional interface, but if you need it to graph on the screen of the meter, well, you're pretty much limited to very few meters that cost a lot more money. But if you want a 50,000 count, very accurate multimeter, and you don't want to go out and buy a bench meter because that jumps a magnitude in price. But this is a really good meter. I know it's big, and it uses a 9-volt battery, which some people are unhappy about because apparently in many places of the world it's not easy to find 9-volt batteries. And yeah, 9-volt batteries do cost a lot more per energy. It'd be nice if it was, they used some double A's in here. But maybe they don't have the room for that. I don't know. So I like it. I'm going to keep it. I would definitely say if you can afford this, what was it, like $176? But it depends on exchange rate and where you're living. If you live in the EU, it's pretty easy to get these. And I don't have enough detail about India and Asia markets to know about that. I've just heard from people that they are available, in Australia, Asia, India. So I hope you guys can get it if you want it. I don't know. Sorry, I don't know enough about that stuff to know where you'd get it from. But yeah, I would not hesitate to recommend anybody. I know, $175 is a lot to pay for a meter when you're a hobbyist, but depending on what you're doing and how deep you're into the hobby and how accuracy needed to be, it could be helpful. And don't forget, there's a lot of other good meters, and some made by Brymen, some made by other people. So if this doesn't exactly fit your bill or your budget, keep looking, because we're reviewing a wide variety of meters. I realize I put the non-third-party safety tested meters kind of at the end of the queue, but I will be getting to those. They're piling up, so I have to get reviewing those. But I personally can't recommend any meter that's not third-party safety tested, but that doesn't mean you shouldn't buy one. It's just my opinion, and that's why I'm going to review them. I'm going to review them after I'm done with all these other ones. So, hope that helps. And this is Tom, N8FDY, saying 73, and take it easy.